And there repeat. Transformations, quadratic functions. This chart is still the same, yes? Okay, same chart we saw. Difference today, our parent function is now x squared instead of absolute value of x. Okay, that is our big difference. Now, the question I was getting ready to ask. What do you remember about quadratic? Do you know what that looks like?
It's the parabola, isn't it?
Okay, yep, it's the parabola. Emily was drawing a U in the air. Okay, or I'm going to call it a U. Okay, so it looks a lot like our absolute value, but it's not the V with the point and two straight lines. It's a U and it's a curve. Okay, now, you know exactly the points for a parabola? Probably not. So what am I going to suggest to get us started? Nice little XY chart. So, give me some good X values.
0.
I always like 0.
1.
-1.
-2.
Okay. And again, you can't just use positives. You're going to miss half the graph if you just use positives. So we're going to use positives and negatives here. We're going to take these X values and substitute them into the original equation. So it was y equals x squared. First thing we're going to do is y equals -2 squared. So -2 squared means we're doing -2 times -2, which is 4. Okay, repeat the process. -1 squared. -1 times -1 is 1. 0 squared.
0.
0. 1 squared.
1.
2 squared. Okay. Now, I'm going to encourage you to kind of memorize that chart. Be very familiar with it. Okay, I'll talk more about it as we use it today. Let's graph it. -2, 4 is left 2, up 4. -1, 1, left 1, up 1. 0, 0. Right 1, up 1. And right 2, up 4. Now, do me a favor. We already talked about this being a U shape. When you connect it, make sure it looks like a U and not a V. Because it's an easy mistake as you connect it to try and make that a point at the bottom. But it's not a point. It is a curve. So just kind of be aware there. And I will say we are all guilty of times of it becoming more pointy than it is round. But your job is to attempt to make that round. When we go to transform, okay, this parabola, and we're moving it left and right and up and down like we did yesterday, I'm going to encourage that you are very familiar with those three pieces right there. The idea that the vertex is at 0, 0. The first set of points go over 1, up 1. And the second set of points go over 2, up 4. Okay, that's the catch, isn't it? Now, before we move down to the bottom, vertex. What is the vertex of this parabola? 0, 0 again. Axis of symmetry. Addie? Yeah. This didn't change, did it? Just like yesterday, the axis of symmetry, the line that divides that U in half to where I could fold it on top of each other, is x equals 0. We could also call it the y-axis. However, it's only the y-axis when it's centered. Once we move it left or right, it's no longer the y-axis, and so x equals 0. Okay, you got your basics for the parabola here, because we're going to keep reusing those points and that shape and everything. Oh. Okay. Hold on a second. Let me delete these extra pages. Sorry, we had a slight issue earlier today in my, there we go. My BenQ glitched everything out, so I had to reload my notes pages midway through the day today. And it just kind of, everything's all out of order now. Okay, Bottom of the page now?
Okay.
Same thing as the bottom of the front page yesterday. Graph the function. We're going to need to know the transformations, the vertex, and the axis of symmetry. So, as we look at y equals x minus 4 quantity squared plus 3, realize what is that parent function? What do you see here? There's an x and there's a squared, yes? So these parent functions that we go through today, you'll see them all have the x squared. You won't see the absolute value bars again anymore. They'll all have the x squared. Now, what do the 4 and the 3 tell this graph to do? What do you got, Ian?
Right 403.
You guys agree with him? He says right 4 up 3. This is that chart at the top of the page, yes?
Yeah.
Okay. A number like the plus 3, added or subtracted out front, is going to, or out back, is going to tell the graph to go up C, yes? What was the other one? Minus 3? But that minus 3 was where? In parentheses. So in parentheses is going to tell us to go right. It's the same piece as you did in the last part of the lesson. So, oh, I had my numbers reversed, didn't I? The plus 3 tells us to go up 3. Because it's a number, it's not in with the x, it's outside of the parentheses. The minus 4 tells me to go right 4. In the parentheses, left or right, opposite the sign. Okay. Shall we try and graph this? Normally, my vertex starts at 0, 0. What am I going to do, though? Yeah. Some combination of right 4 up 3. And that is your new vertex. Which, while I'm here real quick, what is the ordered pair for that vertex? Because that's one thing they want me to write down. If we just went right 4 up 3, what is that vertex? 4, 3. Okay. Okay, here's the difference. Yesterday, to do the absolute value, I just said their lines just go up and over, up and over, up and over, yes? This is an x squared graph. X squared graphs, we don't just get to go up and over, up and over, up and over. So this is where I want you to know these 3 points right here, okay? The 0, 0, 1, 1, 2, 4 is what I will always go back to. So let me put this right over here as a reminder. So the 0, 0 represents the vertex, yes? The 1, 1 says the first set of points are what? Over 1 and up 1 from the vertex. So I have this new vertex here at 4, 3. I'm going to go over 1 to the right and up 1. The 2, 4 says from my new vertex, the next set of points, I'm going to go over 2, up 4. Okay. Now, I just did that on the right side. What else do I have to do? We have to do it on the left side. Okay. It's a reflection. It's across that line, axis of symmetry. So when we went right 1 up 1, we also need to go left 1 up 1. We went right 2 up 4. We also need to go left 2 up 4. And does it look like a parabola? It should. Again, reminder. Try and make it curvier and not pointier at the vertex. Okay. 2 other things. We did the vertex. What about your axis of symmetry?
X equals 4.
Yeah, if my vertex is 4, 3, then my axis, same connection exists, we can say x equals 4. Again, not a coincidence. You're always going to be able to use that first x value. And the other thing we were supposed to do is to identify the transformations. I haven't written those out yet, so I'm going to do that real quick. And these were just translations, right? Translation of right 4 up 3 units. Translations right 4 up 3 units. Okay. This is as easy as yesterday, isn't it? Now, keep in mind, when I'm asking you to do the parabola, I'm asking you to do like those 5 points. The vertex, the first set of points that are over 1 up 1, the next set of points that are over 2 up 4. Savas will kind of make it easier on you. You'll just have to graph. It's just like what we did in that first homework where you grab the parabola tool off on the side, right? You click the vertex, and then you click one other point. So that other point, you can just go over 1 up 1 from your vertex to click your other point. And that should be all you have to do on your parabolas. Okay, let's try this other example. Y equals x minus 1 squared minus 5. What do you got for me? Write 1 down 5. Okay. The minus 1 is in the parentheses with the x, so left to right, opposite the sign. So that makes it a right 1 since it's a minus 1. The minus 5, it's at the end. It's not in the parentheses with the x. It's by itself, so it's up or down, and that is direction of the sign, so down 5. Vertex normally starts at 0, 0. I'm going to go right 1, down 5. There's my new vertex. While I'm here, what is my vertex? What do you got, Thomas?
It would be 1, comma minus 5.
Yep. So we went right 1, down 5, so 1, negative 5. How do we graph the rest of this parabola? From the vertex, I need a set of points that are what? Okay. 1 over, 1 up. Because remember, this is the kind of XY chart I'm going to try and get you guys to remember for parabolas. 0, 0, 1, 1, 2, 4. That represents your vertex. First set of points are over 1, up 1. We can go ahead and do them both. Over 1, up 1. Second set of points are over 2, up 4. Again, make it a parabola, make it curvy, not pointy. Okay, 2 other things to list. Did you list your axis of symmetry? What's my axis of symmetry?
X equals.
Yeah. Remember, I don't want just 1. It's the equation of the line, so it's x equals 1. And transformations. So these were translations. Translation, right 1, down 5 units. Okay. It's not really a whole lot different than yesterday, is it? Different shape is the only thing different. Okay. And I'll be honest, guys. In this lesson, they really wanted me to teach it all together. Lesson 1, 2, all one big lesson. But I felt like that would kind of be disastrous. I felt like we needed to kind of, let's learn the absolute value of V's. Let's learn the basics with that. And then transition it to this. So. Okay, what happens when we get to the backside?
Get fractions.
We get fractions. Are we still going left and right and up and down?
No.
Yeah.
I mean, we could be, but do these have any adding and subtracting options? No. So these are not going. We're not going to be taking these parabolas and moving them left to right or up or down because they're not adding and subtracting any numbers. Those fractions are being multiplied. What happens when there's a number multiplied by x squared? This is your stretch or compress. If you go back to that chart, remember? Number multiplied out front, that is your stretch or compress. On my first example, it is what? 1/3 x squared? Where does 1/3 fall? Stretch or compress?
Compress.
1/3 is a number less than 1, correct? So since it's a number less than 1, we're going to compress. So it asks us to graph, it asks us to identify the transformation. I'm going to just write it down here that it is a vertical compression by factor of 1/3. Okay. What about my vertex?
Just gonna stay at 0.
Right? I'm going to stay at 0, 0. I don't have anything telling me to move left or right. I don't have anything telling me to move up or down. Compression or stretch is going to keep me at 0, 0. So, now, here's the different part from yesterday. Yesterday, because we were doing straight lines, we could just treat this fraction as a slope. Today, a parabola is not straight lines. It's curves. So this is no longer a slope. Okay? I know. Life would be so much easier if it was a slope. It's taking your x squared values and multiplying them by 1/3. I'm going to take you through my suggestion is that we think about it like an XY chart. And I'm just going to do like the right side. And then we can reflect to get the left side. Now on the right side, we normally use what? 0, 1, 2? Where 0 represents a vertex. So I still like 0. Are you going to like 1 if we put it here? No, because I'm going to do 1 squared and get 1 multiplied by 1/3, and now I have to graph 1/3. We don't want to use 1. So with that in mind, do I want to use 2? 2 squared is 4 times 1/3. Yeah, then we're in fraction world again. What kind of numbers do I want to use here for these other two x values? What are you thinking, Ian?
3 and 6.
Why 3 and 6? I like them. Why?
Because they go into the fraction.
Okay. They go into the fraction. I always say when you have a fraction, look at your denominator. My denominator is 3. Use multiples of 3 is what I'm going to tell you. Okay? 3 and 6 are multiples of 3, so we're gonna have some canceling going on. Okay, so 0, 0 is still going to be my vertex. Or you can do the math. 0 squared times 1/3, it's still 0. Let's plug in 3. So 1/3 times 3 squared. Now, I tend to say, let's talk about Aunt Sally right here. And I get some weird, crazy looks at times. You guys don't think Aunt Sally. Anyone knows Aunt Sally? Yep, PEMDAS. Please excuse my dear Aunt Sally is how I learned it. I still think that's taught on occasion, but more often than not, you guys know PEMDAS. And I'm only mentioning Aunt Sally or PEMDAS because we have to know. Do we multiply or do exponents first?
Exponents.
Exponents and then multiply. So 3 squared is 9. And then we're doing 1/3 times 9. What is a third of 9?
3.
3. It's 9 divided by 3, yes. So it is 3. Let's put in 6. 1/3 times 6 squared. 6 squared is
36.
36. And then we're doing a third of 36. What is a third of 36?
12.
12. 36 divided by 3 is 12. Okay, so we already talked about 0, 0. From 0, 0, one of my points is going to go 3, 3. So we're going to go right 3, up 3. My other point that we found is 6, 12. 6, 12 is going to go right 6 and up 12. Now, you will quickly notice these grids that I usually use are 10 by 10 grids, aren't they? I don't care if you count 2 off the grid. I mean, come on. That's not that far off. I tried to set it up. Does that kind of look like 12? You know, I kind of try and make it look like 12. If you need to go off the grid a little bit, it's fine. Okay? Obviously, it's a little bit different if, you know, you're trying to count up 30 or something. Then we might talk about counting by a number. What's the word I'm looking for here? Relabeling that axis, okay? Scaling it, that's the word I'm looking for.
Do they normally follow that pattern? Like how it's 0, 0, and then it's like the multiple of 1, and then it's the first number, then it's doubled? Because like on the other one, it's 0, 0, 1 and 1, and then 2 and 4. And how 3 and 3 can be the same, and then 6 and 12 is like half of itself. Is it normally following that pattern?
No.
Just
I had to stop and think. Again, it depends. A lot of it depends on what we're looking at there. So, okay, now all I've done is put the points for the right-hand side. Did you put your left-hand side in? If we went 3 right and 3 up, we also have to go 3 left and 3 up. If we went 6 right, 12 up, we have to go 6 left, 12 up. So, easiest way I can teach this is to just kind of think about a couple of x values. There's some other ways I could teach it, but that's easiest for me. Questions there? Okay, let's try the next one. Y equals negative 3/4 x squared. Thoughts on what you see with negative 3/4 x squared?
3/4 is negative.
3/4 is negative. That means something to us, doesn't it?
You reflect it across the x-axis.
Okay, and negative, remember we talked about that yesterday, a negative is a reflection. A negative out front is specifically a reflection across the x-axis. So we're going to have there, we're going to have the reflect. What's the 3/4 going to do? Okay, it's a multiplying number out front, so it's either a stretch or a compress. Because it's a number less than 1, it's going to be a vertical compression. Okay, so I'm going to come down here real quick and write that out, and then we'll do the graphing. So it was reflect across the x-axis and vertical compression by factor of 3/4. What do you know about the vertex? It's an x squared graph. We're not moving it left or right or up or down, so that vertex is going to be 0, 0. But we need some other points, don't we? So this is where, again, I'm going to set up an XY chart. I always put 0 in here, but 0 just represents that vertex. I ask you for 2 more points. I mean, some of us will only require 1 point, but I ask you for 2 more points. What numbers would you like to put in? Do you want to put 1 in? I personally am not wanting to put 1 in because I'm going to end up with a fraction or decimal answer. What are thoughts here if I don't want to use 1, 0, 1, 2 like normal? Vetoing 1. Thomas?
Just like 4 and 8.
Could use 4 and 8. 4 and 8 because they're multiples of 4. What were you going to say, Ian? What?
I was going to say 2.
Could we use 2? You could. Okay, now, I know it's not a multiple of 4, is it? But when we go to do 2 squared, we're going to get 4, which will then cancel with the 4. Okay, so now, is 4, 8 wrong? No. I'm going to tell you, though, the bad news, 8 gets you kind of a big y value. Okay, so I like 0, 2, 4, if you can think about the 2. Otherwise, 0, 4, 8, it works. Okay, so 0, 2, 4 is what I would go with. I'm not against 8, though, because 0, 4, 8 is the rule I taught of multiples of 4, yes? So both are good. Okay, 0. Officially, you put 0 in. 0 squared is 0. Multiplying, you still get 0. We expected that. Now we're going to put 2 in. So negative 3/4 times 2 squared. We know 2 squared is 4. So now it's negative 3/4 times 4. 4 as a fraction is 4 over 1. I teach cross-canceling. The 4 in the denominator cancels with the 4 in the numerator, and we have left negative 3. Or negative 3 over 1, which is equivalent to negative 3. Okay, let's put in 4. Negative 3/4 times 4 squared. 4 squared is 16. So negative 3/4 times 16. Again, I don't know how many of you like to cross cancel. I'm not sure how much it's taught anymore, but that's what I like to do. 4 and 16. Both divide by 4. 4 divided by 4 becomes 1. 16 divided by 4 becomes 4. And then I have negative 3 times 4, which is negative 12. Right there, we're already at negative 12, and we haven't even used 8 yet. Just saying. Okay, what? 8 squared is 64. 64 divided by 4 times 3. Oof. You're getting big. We're very big into the negative. So, okay, 0, 0. 2, negative 3. Right 2. Down 3. Now, if we go right 2, down 3, we also need to go left 2, down 3. And 4, negative 12. Right 4, down 12. If you go right 4, down 12, we also need to go left 4, down 12. My parabola appears to be upside down. Are you okay with that? Because we said it reflected. So it should be upside down. If it's not upside down, that's when I'm not okay with it. Okay, got it? This is a part you have to think a little bit about, but it's doable. Okay, we have the bottom section to look at here, and you'll see this on my next page too. This looks familiar to a form we talked about with absolute value, wasn't it? Then it was A times absolute value of x minus h plus k. This is A times x minus h squared plus k. This is just a quadratic form. A is still the stretch or compression. HK is still the vertex. And that's just how much left or right and up or down you're going. Now, in these two examples, we're asked to write the quadratic function of the form that we just talked about. Basically, I want you to write the equation. There's the graph. You create the equation. Now, okay, let me write out the basic form. A times x minus h squared plus k. So I need to know three things. A, h, and k. Those are the three pieces I have to know. Easiest to know are h and k, because h and k is my vertex. What's my vertex on this example? What is that, Raja?
-4 over 1 negative.
Okay. So it's going to be the ordered pair -1, -4, yes? So -1, -4, those are my h and k values, aren't they? We went left 1, down 4. And you don't even have to think of the numbers -1, -4, just think left 1, down 4. So we'll fill those in a moment. The other part we need to know is A. That is your vertical stretch or compression. What I would do, look at your vertex. Where is the next point going from your vertex? It is what? Just over, is there a point over 1, up 1?
Mm-hmm.
Okay, if there's a point over 1, up 1, that is just like, remember my original parabola of the day?
Mm-hmm.
That's just like my original parabola. Over 1, up 1 is a basic parabola with no stretch or compression. So you're just, A is just going to be equal to 1 there. Does that make sense? Am I making sense, what I'm saying?
Yeah.
So since that just is over 1, up 1, that's just my A value is going to be 1. So let's write this equation. Y equals, first time through I'm going to write in the 1, but it's a 1 multiplying. You don't really have to write in. X minus, what did we say H was? -1. So you can think x minus -1, quantity squared, but minus a negative is the same as a plus. And does x plus 1 make sense there?
Mm-hmm.
Yeah, because I would tell you to go left 1. And then plus k, well, plus k in this case is plus -4. We don't usually write plus -4 though at this level, do we? Plus -4 you would write as -4. So I would be looking for a y equals x plus 1 quantity squared minus 4. And that's what Savas is going to be looking for too. Savas might get mad and count it wrong if you say plus -4. Annoying, I know, but they will. Savas might get wrong and count it wrong, or might get mad and count it wrong if you put that 1 out front. Annoying, but they might. They might not. I don't remember for sure. Okay, I have time for one more? Barely. Same idea, guys. Filling in y equals a times x minus h squared plus k. So what do we know? Vertex is
-2,
-2, -5. Or, excuse me, you said it, right?
Yeah.
-2, +5. So -2 and 5 are my H and K, yes?
Mhm.
And then, besides that, we need an A value. So here's what I'm going to say here. Find the first point you can. And where is that first point? Looks like it's right there. Which is what? That is going to be over 1 and okay, whoa. I was going in order from the vertex. I'm like, where are you guys getting up to?
down.
Okay. In relation from the vertex is what I'm saying here. Like this point was 1 over and 1 up from the vertex. Sorry. Here, from the vertex, this is over 1 and down 3. Okay? The fact that it is over 1 and down 3, okay, that tells me, so normally we go over 1 and it would be down 1, yes? Since this went 3, that's a multiple of 3. And so since it went over 1 down 3, my A value, or my stretch, is going to be a factor of 3. Okay? Because we're going down, what also has to happen? It's negative. Okay? So when we go to write this out, and sorry, I know I'm rushing, but I'm running out of time. A is -3 times x minus -2, quantity squared, plus 5. If I clean that up, y equals -3 times x plus 2 squared plus 5. Okay? If it just goes over 1 and up or down so many to that next point, you can just use that number. That's kind of a shortcut. Okay? So it's almost kind of like a slope when it's just going over, up, over one or the other. Okay, guys, your homework. Lesson 1.2. It's called quadratics. It would be available now. It's going to be due tomorrow. It should be similar to the homework you just did.